This is the first page of the fall AB final exam review packet, multiple choice. So we're going to work through the first page here, 1 through 7. So number 1 says the domain is, so we want to find the domain of this expression. So there's going to be restrictions from both the numerator and denominator. So the domain is going to be the combined restrictions of these two, numerator and denominator. Okay. Or the most restrictive between these numerator and denominator. So if we look at the numerator, square root of x minus 2, this portion, if we just treat this by itself, the domain for this portion of the graph is just going to be from 2 to infinity, right? Any value less than 2 will not exist for the top portion. Now the denominator, the issue here is we want to look to see what will cause denominator to be 0, because that's also going to be part of our domain. So if we set the denominator equal to 0, we get x times x. We can factor out the x times x minus 1. So x equals 0, x equals 1. Now 0 and 1, they both fall outside of the domain, so it really doesn't matter. The most restrictive between these two is going to be x is greater than or equal to 2. Okay, so any value that's other than 0 and 1 will be safe for the denominator, but 0 and 1 and also any value less than 2 is just not going to work here. So we combine these two restrictions, and we see the more restrictive is the numerator. So our domain for this entire expression is just going to be x is greater than or equal to 2. So from 2 to infinity, d. Number 2, which of the following function is not odd? So odd function is where f of negative x is equal to negative f of x. So meaning that if I can replace every x with negative x in the original function, and if I clean that up, is that going to be the same thing as factoring out a negative in front of the function? Okay. So what we do know is that sine function is odd. So sine of negative x is equal to negative sine of x. So that's true. And because sine curve is odd, sine of 2x is also odd. So sine of negative 2x is also negative sine of 2x. So that's also true. Now the third one here, if I replace x with negative 1, I get negative x cubed plus 1. That's not the same thing as putting a negative outside the entire function, because if I distribute the negative through, I get negative x cubed minus 1, and that's obviously not the same thing as negative x cubed plus 1. So C is the one that's not odd. Okay, these two are also odd, but I just want to go through this as well. So if I replace every x with negative x, I get negative x over x squared plus 1. The denominator stays positive here. So negative x over x squared plus 1 is same thing as factoring out a negative outside with x and x squared plus 1. So these are the same, so we know that's odd. Okay, and cube root of negative 2x is the same thing as negative cube root of 2x. Okay, so the cube root is not going to affect the negative. Either can be either inside or outside. So we know this is also an odd function. Number 3, which of the following is a reflection of the graph over the x-axis? So A is the answer. So this is going to be x-axis reflection. Let me just go through these other ones so we kind of know what they are. F of negative x is going to be a y-axis reflection. Okay, y is equal to absolute value of x. This is basically going to be taking any x value, any y value that sits below the x-axis and transform it to be a positive value. So basically, any value that sits below the x-axis will be flipped over above the x-axis. So this is what this is going to do. It's going to transform. The transformation is that any portion that sits below will now be above the x-axis. Y equals f of absolute value of x. So here, this graph is only going to display portion of the graph to the right of the y-axis. Okay, because any negative value that you try to plug in, it will turn into a positive value, and it'll only display values that's to the right of the x-axis. Okay. Negative f of negative x, this is going to be a 180-degree rotation about the origin, so the answer is A. Okay. Number 4, limit as x approaches 3. Remember, the first thing that we do if we're trying to evaluate a limit algebraically is we plug in that target x value. So if we plug in x, or if we plug in 3, we get 3 minus 3, which is 0. 9 minus 6 minus 3, which is also 0. So if we get 0 over 0, then that tells us that we have to keep going with this problem, okay? Meaning that we want to look for some common factors that we can reduce and simplify, and allowing us to hopefully reevaluate. So if we look at the denominator, we can factor this out to be x minus 3 times x plus 1. And the factor in the denominator and numerator are going to match. I can cancel out between numerator and denominator. I can rewrite the simplified expression being 1 over x plus 1. And if I plug 3 into the remaining x, I get 1 over 3 plus 1, which is 1/4, and that's our limit. Okay, number 5, limit as x approaches 0 of x over x. First thing we do is plug in 0. We get 0 over 0. So that tells us we need to keep going with the problem. So the x's cancel out. It leaves us with 1. So limit is just going to be 1. Okay, number 6, limit as x approaches 2 of x cubed minus 8 over x squared minus 4. If we plug 2 in for x, we get 8 minus 8 over 4 minus 4, 0 over 0, indeterminate form. So that tells us that we have to do something more to clean up this expression so that we can reevaluate the limit. Now this is in the form of a difference of cubes. 8 is a perfect cube, and so is x cubed here. So we can rewrite it as x cubed minus 2 cubed. So the formula for difference of cubes is a cubed minus b cubed is a minus b times a squared plus ab plus b squared. We also have this acronym to help remind us or help us remember the signs, because if it's a cubed minus b cubed,